Okay, let's jump right into this. Welcome to today's explainer, where we're putting on our hard hats and taking a highly detailed, systematic look at the engineer's tray installation inspection, specifically focusing on trough cable trays. If you're running EPC or MEP teams, you already know that a cable tray isn't just some random piece of metal holding wires up. No, it's the absolute vital physical infrastructure of your entire facility. So today, we're going to break down exactly how to secure those installations, moving seamlessly from that very first initial specification all the way to your critical site inspection. Our workflow today covers the complete life cycle of a tray project. We're hitting 5 key areas. 1. Tray terminology and myths. 2. Handling 8 root conditions. 3. Avoiding mismatched fittings. 4. The 10-point pre-installation check. And 5. An international compliance summary.
Section 1. Tray terminology and myths. Let's start with a massive headache that often derails a project before it even gets off the ground.
I'm talking about the total chaos of inconsistent terminology. By definition, a trough cable tray is a system specifically designed to provide more continuous cable bearing than your standard open designs. But here is the pitfall, and it's a huge one. Engineers and contractors frequently just slap generic terms like U-section onto their spec sheets. You simply cannot do that. EPC and MEP teams have to specify exactly from a selected product family to guarantee true structural integrity. Your profile, fittings, covers, support, and finishes, they all need strict, specific confirmation. If you just assume a generic description is going to magically translate into perfectly integrated parts on site, well, you're literally setting the project up for failure. The core physical difference here is pretty stark. Trough trays give you that continuous, often fully enclosed bearing and support. Ladder rungs, on the other hand, feature an open design with way less continuous support. Now, this is exactly why trough trays are your go-to when continuous support is absolutely non-negotiable. But because they are enclosed and continuous, we can't just assume generic support fittings will do the trick. Every single piece needs to be engineered to fit together like a lock and key. Section 2, handling 8 root conditions. So, knowing those baseline structural differences, how do we systematically match our tray type to the actual real-world conditions of the site? It comes down to evaluating route conditions. We're talking about ventilation needs, moisture exposure, heavy load bearing, and continuous support requirements. We have to ruthlessly compare capabilities. When we look at trough, perforated, and solid bottom trays, we can map out exactly where trough support is the perfect fit. But honestly, it's equally important to identify where a trough tray might actually underperform compared to an open ladder or perforated tray. Like in environments demanding maximum passive heat dissipation, a fully enclosed trough might work against you. The takeaway? Selection isn't about guessing, it's about systematically mapping your hardware's capabilities to exact environmental demands. Section 3. Avoiding mismatched fittings. All right, once you've rigorously selected the ideal tray type, we move to the procurement phase. And oh boy, this introduces one of the most dangerous traps in engineering. Why do fitting mismatches actually happen? Well, it usually starts with a visual illusion. Just because a fitting looks right on a spec sheet or in a slick catalog doesn't mean it'll actually match your selected components on site. You can run into mismatched rail profiles, entirely incompatible width or depth dimensions, or cover interface alignment failures. Think about it. A tiny 2mm difference in a rail profile might look identical on paper, but out on the site, that means your cover absolutely won't snap in, your structural integrity is compromised, and the entire installation just grinds to a halt. To fight this, MEP teams have got to strictly follow a pre-order release checklist before authorizing a single dime. Step 1. Validate product family consistency across every single part. Step 2. Confirm exact rail profile compatibility. Step 3. Verify all width, depth, and cover interfaces. Only then do you reach Step 4, which is signing off on the final MEP procurement order. Implementing this specific checklist prevents those ridiculously expensive, project-delaying mismatches upon delivery. It takes all the guesswork out of procurement and anchors your decisions in verifiable data. Section 4. 10-point pre-installation check. Fast forward to the construction site. The materials have arrived safely, they match perfectly, and the EPC contractor has successfully mounted the trays. Now, we face the moment of truth. The tray is up, the route looks fantastic, but is your site actually ready for cable pulling? You might be tempted to think the job is ready for the next phase, but look, initiating a cable pull without a formal engineer's tray installation inspection is an absolute recipe for disaster. Once those heavy cables are loaded in, Trying to go back and fix a structural flaw is incredibly difficult, not to mention wildly expensive. This brings us to the mandatory 10-point route review. We start with the top 5 structural checks to guarantee the physical framework is completely sound. Number 1, verify continuous cable bearing integrity. Are there any hidden gaps? Number 2, confirm that the correct rail profile connections are locked in securely. 3, you've got to check fitting and support alignments to make sure there's zero undue stress on the tray itself. 4, validate the width and depth consistency across the entire run. And 5, deeply inspect those structural load-bearing points. This right here is the absolute backbone of your installation. If these 5 points aren't perfect, the system cannot safely support the cable weight, period. Then we round it out with the final 5 clearance and safety checks. These act as the engineer's ultimate shield before a single wire is touched. Check 6. Verify that the cover interfaces are fully secured. 7, and this is incredibly critical for the health of your cables. Inspect the entire route for any sharp edges or snag risks. A single burr can strip a cable jacket right off during a pull. 8, confirm the proper finish application is completely intact to prevent long-term corrosion. 9, double-check that the routing still actually aligns with the environmental conditions we evaluated way back at the start. And finally, point 10, the formal final sign-off. The site is only released for cable pulling after this signature is on the page. Section 5, International Compliance Summary. Of course, a flawless, highly detailed inspection checklist is really only as good as the underlying manufacturing standards of the tray itself. So let's talk about the baseline of quality. According to our sources, manufacturers like Xinma ensure that every single component you're evaluating complies strictly with rigorous international standards. We are talking about heavy hitters like IEC 61537, NEMA VE1, BSEN 50085, and GB 31251. Now, these aren't just random letters and numbers to make a spec sheet look good. These are the strict global benchmarks for safe, durable, and reliable cable management. When your product family is built to these standards, your 10-point inspection isn't just about catching contractor errors, it's about officially validating an already world-class engineering solution. And these standards matter everywhere because Xinma-supported applications cover some incredibly demanding environments. Whether you're deploying intelligent cable management and heavy-duty busways in a high-density data center, installing seismic bracing for a rail transit system, or outfitting complex industrial plants and massive commercial buildings. It's these baseline manufacturing standards, combined directly with the rigorous installation checks we just walked through, that ultimately secure your entire infrastructure. We've covered a lot of ground today. We've walked through the entire life cycle, from avoiding generic terminology myths right at the start to selecting the exact right tray for your route, dodging the mismatched fittings trap, and executing a flawless 10-point structural and safety review. So I want to leave you with this final thought. Before your next massive cable pull gets underway, ask yourself and sit down with your MEP team and ask them, is your current inspection checklist truly comprehensive enough to prevent a catastrophic failure?